So now the next chapter is battery testing and design consideration. So here we will see some techniques related to battery testing. Okay. So before going to start that particular testing, so do you all know that what is a nominal capacity for a storage component like battery? So the nominal capacity is also known as rated capacity. Okay, so it is also known as rated capacity, which refers to the amount of energy that can be withdrawn from a fully charged battery at a particular constant current. And it is an essential specifications for understanding the energy storage capability of any batteries. So the question is like, does the nominal voltage of a battery vary, or is there any differences in the voltages? So obviously, yes, the nominal voltage of a battery depends on the specific chemical reactions which is happening within it. Okay, and however, it is important to note that the nominal voltage is just a average value. Okay, so it is just a average value, and the actual voltage of the battery will be decreases as it discharge. Okay, so how do we calculate the capacity of a battery? Okay, basically it will be calculated in kilowatt hours. So the capacity of a battery in kilowatt hours can be calculated by using this particular formula. Okay, by using this formula. So here you can see a capacity in kilowatt, which is equals to capacity in ampere. Then after it will be multiplied by a operating voltage, uh, and then it will be divided by 1000. Okay, so this formula consider both the nominal capacity in ampere hours, which will be in your Ah, or the operating voltage of the battery. So the actual usable energy of a battery depends not only on its nominal capacity but also on its operating voltages, because the operating voltages plays a significant role in determining the actual energy and the output of the particular battery. And it is also essential to consider both factors when evaluating the performance of a battery. So how does this relate to a practical usage? Okay, so understanding the nominal capacity, which help us gauge how much energy a battery can provide under ideal conditions. Okay, for example, if a battery has a nominal capacity of 600 ampere and a nominal voltage of 12 volt, and its overall nominal capacity will be something around like 7.2 kilowatt. Okay, when you will put this nominal voltage and nominal capacity into this particular formula, so you will get the like its you can say norm capacity. Okay, nominal capacity in kilowatt hour, which is a 7.2 kilowatt kWh. But here you can see we are converting watt hour into kWh. Okay, so when you will add the 600 into 12 volt, you will get 7200 watt. So you have to convert this particular watt into kilowatt. Okay, so what about the discharge current? So what about the discharge current? Okay, so the discharge current, or a rate at which the battery is drained, is also important, because the nominal capacity is usually provided at a specific discharge rate. and which is sometimes denoted as C rate. Okay. For example, if the nominal capacity of a battery is 600 Ah, okay, 600 Ah, and the discharge current rate is 25, okay. So the corresponding output will be your 24 hours if you will divide 600 Ah by 25 ampere, okay. So what's the usable capacity, okay. Then suppose, so what is the usable capacity? So the usable capacity is the amount of energy that can actually be used for from the battery before it needs a recharge, okay. And it's basically expressed as a nominal capacity, which is multiplied by the maximum depth of discharge, or we can say DOD, okay. For like for a lead acid batteries, the usable capacity is usually 50%, okay. 50% of the nominal capacity, okay. Here you can see 50% of the nominal capacity.